Hello everybody, let's go over some of the questions from the practice test. Right, number 1, find the derivative of the function y equal to the quantity of 7x to the 4th minus 3x squared plus 1 to the 4th power. So to find the derivative for this, we will need to use chain rule. So in order to use chain rule, we will have to recognize what our u would be. So to help us identify what u would be, we will have to think of what known formula we can use to differentiate this. So if you recall, we have a formula for the derivative of u to the n, the power rule. So if we differentiate u to the n with respect to x, the derivative of u to the n is just equal to n u to the n minus 1 times the derivative of u with respect to x. So in this case, our u, which is g of x, is just the expression inside the parenthesis or the base. So if we let u be equal to 7x to the 4th minus 3x squared plus 4, then we will be able to use the power rule. And so to differentiate this, we follow the formula here. So we have the derivative will be 4. You bring down the power, and then you copy the base, so times u, which is 7x to the 4th minus 3x squared plus 4 raised to n minus 1. So our n is 4, minus 1 is 3, times the derivative of u. So times the derivative of u with respect to x. Then you differentiate the base here. So now differentiate 7x to the 4th. That is equal to 28. So you multiply 4 times 7. So that's 28. X to the, then you subtract 1 from the power here. So 4 minus 1 is 3. Minus, and then you multiply 2 to negative 3. So that is negative 6x. Because then you would have to subtract 1 from the power here. 2 minus 1 is 1. Then you differentiate 4. That's a constant, and that is just equal to 0. Now, you can, I would say, put a parenthesis here just to make sure that you are multiplying the expression here by everything inside this parenthesis. And then you can input your answer like this in MyMathLab, and that will be marked correct. Now let's look at number 2. Find the derivative of the function here. In this case, we would still use chain rule to differentiate this function. Now to use chain rule, let's identify what u would be. Here, we would recognize that we could use the power rule, which is u to the n. The derivative of u to the n with respect to x is equal to n u to the n minus 1 times the derivative of u with respect to x. Therefore, in this case, we would let this be equal to u. So we would let our base be equal to u. So u is equal to 7x to the 7x squared plus 6. So if that is your u, then your kx will be of the form negative 4 u to the negative 6. Then you'd be able to apply the formula here. Okay, so now let's find the derivative. To find the derivative, you follow this pattern here. So you will multiply negative 6 to negative 4. That is equal to 24. Negative 4 times negative 6 is 24. and then u, copy your u. U is 7x squared plus 6. And then you subtract 1 from the exponent here. So that's equal to negative 7. Negative 6 minus 1 is negative 7. Then you don't stop there. You multiply it by the derivative of u, the derivative of the expression here. Then you go ahead and differentiate 7x squared. That is equal to 14x. And then the 6, the derivative of 6 is just equal to 0. Now, as I've said, you could input your answer for your test in MyMathLab as this. You just make sure that you put that multiplication symbol here. And sometimes it's better if you just put parentheses. Just be generous with parentheses, especially if the expression here is composed of 2 terms. In that case, you make sure to enclose it in a parenthesis. Now for the next question, we are to find the derivative of the given function here. Notice that this function is a rational function. So that means to find the derivative of y with respect to x, we're going to use the quotient rule. Now let's recall the quotient rule. So recall, we can use uv, so this is of the form u over v. To find the derivative of u over v, the derivative of that is just equal to log, so the denominator, v, times the derivative of the numerator. So log d high, that's u of v u prime minus high, so your u, the log, v prime, all over log squared. So that's the formula that's the quotient rule. So applying quotient rule to the expression here, this is your v, that's your denominator. So that's 4x plus 2 to the 8. So you copy v, times you differentiate u, times the derivative of u, which is 6x minus 1. Again, make sure that you enclose it in a parenthesis. Otherwise, the computer would think that you're only multiplying 6x to the expression here. Okay, so enclose this in a parenthesis. And then minus, copy u. So that is 3x squared minus x. Again, enclose it in a parenthesis. Times the derivative of v. So times the derivative of the expression here. Now, you should recognize that to find the derivative of the expression here, you have to use chain rule. So this is of the form u to the n. So that means the derivative is 8 times 4x minus 2, so that's your u, to the 7th, because 8 minus 1 is 7, times, you don't stop there, the derivative of u, times the derivative of the expression here, which is 4. Most students would forget this 4 here. So remember, when you use this formula, the derivative of u to the n with respect to x, you have n, u to the n minus 1, and then times the derivative of u with respect to x. Okay, so that's the numerator. All over the denominator v squared. So that is 4x minus 2 to the 8 quantity squared. So that means you just multiply these two. That is equal to 16. Now, the good news is you can input your answer like this, and MyMathLab would accept that. All right, next problem. We are to find the derivative of y equal to the square root of 4x plus 2. So to solve this, we are to use chain rule. Now to use chain rule, we would write this as, let's write this first as 4x plus 2 to the 1/2. Then we recognize that we will use the power rule, which is the derivative of u to the n with respect to x. And that is equal to n, u to the n minus 1 times the derivative of u with respect to x. So let's apply that to here. So we have y prime is equal, or y prime or dy dx is just equal to 1/2, that is your n, the power, times 4x plus 2 raised to 1/2 minus 1. 1/2 minus 1 is equal to negative 1/2. And then times, don't forget, the derivative of u with respect to x. So the derivative of u with respect to x, so times 4. Now, if you look at the choices, that means you need to simplify this. So in this case, you need to write it in its simplest form. So if you remember, if the exponent is negative, to make that exponent positive, you have to put that in the denominator. So you will have, so this 4 here remains in the numerator, because 4, that means the denominator is 1. Or you could also simplify the 4 with a 2 here. That gives you a 2. So that means you have a 2 in the numerator all over 4x plus 2 raised to 1/2. Now, if it is raised to 1/2, you could write this in radical form. See, therefore this is equal to 2 over the square root of 4x plus 2. And that is letter C. Right, for the next problem, we are to find the derivative of the function here. Now, before you proceed, you make sure to actually look at this expression here twice, and then notice that this one contains a variable t, and this expression also contains a variable t. So that means that we are to use product rule in this case. Now, because there is a variable t here, then you could think of this as a function. So one function. So for instance, this is your f of t, and this one would be another function, g of t. So these two functions are being multiplied together. So that means we're going to use the product rule. So what is the derivative of the product? So for instance, if you have u times v, you differentiate those with respect to x, that is equal to u v prime plus, so u v prime plus v u prime. Multiplication is commutative, so it doesn't matter which one you do first. So using that formula and applying that to here, to find the derivative of m with respect to t, so or m prime of t, that is just equal to, copy the first factor first, so copy negative 7t, just enclose that in a parenthesis. So you know that that's a factor, okay, or that's one function, times, now the derivative of g of t, so times the derivative of 2t to the 4th minus 1 quantity to the 6th power. And the derivative of that is equal to 6, you use chain rule, 6 times 2t to the 4th minus 1 to the 5th, so you subtract 1 from 6, times the derivative of what is inside, so the derivative of 2t to the 4th minus 1. The derivative of that is 8t cubed. And then minus 0. The derivative of 1 is 0. So that is for uv prime. So now plus, copy v, which is 2t to the 4th minus 1 to the 6th times u prime, the derivative of u here. So that is equal to negative 7. So enclose that in a parenthesis. And as I've said, you can input your answer like this. Now for this next question, we are to find the derivative of this expression. This also is going to use the product rule because you have a function here multiplied by another function. Question, how would you know if you have a function multiplied by another function if the expression contains the variable? So this one is one expression, it contains a variable. And then this expression here also contains another variable or the same variable. So that means that you could think of these two here as a product of two functions. Now, let's use the product rule to solve this. Okay, so you could think this, you can think of this one as your u, and this could be your v. So y prime is just equal to u v prime plus v u prime. And so y prime is equal to your u, that's your u, x plus 6 to the 4th times the derivative of v. So times e to the negative 3x, the derivative of e to the u is e to the negative 3x times, and you use chain rule here, the derivative of negative 3x, which is negative 3. Just enclose that in a parenthesis. So that is your v prime. Plus, copy v, which is e to the negative 3x times the derivative of u. This is your u. You use chain rule there. So you have 4x plus 6 cubed times 1. The derivative of x is 1. Now, because this is a multiple choice question and you look at the choices, you notice that they're actually simplified. So in this case, you are to simplify this. Now, to simplify this, let's just go look for common factor first. So notice that we have x plus 6 to the 4th here, and you have x plus 6 cubed here. So that means that we have a common factor that is in terms of x plus 6. So you copy x plus 6. Now, which power? You pick the smallest power. So you have cube. So x plus 6 cubed is a common factor. What else? E to the negative 3x is also a common factor. So you copy e to the negative 3x. Then you have, now you see which one is left. So after I factor x plus 6 cubed here, I would have x plus 6 left. Okay, so I would have x plus 6 still. And then, yeah, and then you can check. You multiply this by that, you should get x plus 6 to the 4th. And then times negative 3. You would also be left with that negative 3 after you factor out the e to the negative 3x. Plus, now in this case, if you remove this part and you remove this, you will be left with 4. And then you simplify this. Okay, so you just copy x plus 6 cubed e to the 3x. And then now you simplify this. So you distribute negative 3 to each term in the parentheses. So you have negative 3x minus 18 plus 4. And then you simplify. So you have x plus 6 cubed e to the 3x to the negative 3x times negative 3x minus 14. Which one is that? Now, if you look at this, oh, they're all positive. So you could take out the negative sign here because they're both negative. So that gives you the negative of x plus 6 cubed e to the negative 3x, or you could place that, after this expression here. Then if you take out the negative sign, you will have 3x plus 14. And which one is that? That is letter C. Next, let's work on this problem here, where you have 5e to the 4x squared minus 4. Now you are to find the derivative of the function here. In this case, we will have to use chain rule. Do we need to use product rule? No, because this is just 5 and that is just a constant. So you can use a constant multiple property. So just use, in this case, chain rule. So using chain rule, you are just going to think of this as e to the u. So e to the u. So we're going to use the formula for the derivative of e to the u. E to the u, the derivative of e to the u with respect to x is just e to the u du dx. So here, you copy first 5, because that's a constant, times the derivative of e to the u. So e to the 4x squared minus 4 times, and then you differentiate u, which is 8x. And that's it. Now this case, it's easy to simplify. You can go ahead and simplify it. That's 40x e to the 4x squared minus 4. All right, so for this next question, we are to find the derivative of x to the 8 times e to the x. So I hope you recognize that to find the derivative here, we would need to use the product rule. All right, so let's apply the product rule. This would be your u, and this would be your v. So recall the derivative of u times v with respect to x is equal to u v prime plus v u prime. So the derivative here is just equal to the derivative y prime, or dy dx, is just equal to u, so that's x to the 8, v prime, the derivative of e to the x is just e to the x, so you have e to the x, plus v, you copy e to the x, and then you differentiate u. That is 8x to the 7th. So you have 8x to the 7th. Okay, that's it. Next, let's find the derivative of the given expression here. So notice that this is also an exponential function, but in this case, the base is no longer e. So we have a formula for that. We have a special formula for the derivative of a to the u, where the base is no longer e. So recall that the formula for a to the u, again, the base is not e with respect to x, is just equal to a to the u times the derivative of u with respect to x and times ln a. Or I would say write ln a before, so you won't forget that. So ln a, ln of the base, times a to the u times the derivative of u with respect to x. So in other words, to differentiate this, you copy that negative sign first. So copy negative, and then the base here is 2. So 2 to the, now you would say negative, and then I have said you copy ln a first. So negative, or you write ln a first. So negative ln 2 So you copy the negative sign and then you write ln2 times a, so that's 2, to the 10x squared minus 1 times the derivative of u, so times 20x. Now let's have another function or another example on differentiating exponential function of the form a to the u. So let's find the derivative of 7 times 4 to the square root of x minus 2. Now here we do not use the product rule because this is just a constant. So we will use the constant multiple rule. And so you copy that 7 to find the derivative. Just copy 7 times, and then you differentiate this. So this is, you're going to use the formula for a to the u here. The derivative of a to the u is equal to ln a times a to the u du dx. So the only difference between the derivative of a to the u and the derivative of e to the u with respect to x is the ln a. You don't have ln a because you know ln e actually is just equal to 1. So essentially they're just the same. So because you have e to the u, if you follow that formula, you will have ln e to the u, du dx. But ln e is just equal to 1. That's why we don't write that anymore. Okay, so let's go back to the problem here. So copy 7 first and then differentiate 4 to the square root of x minus 2. So you copy ln, you would write ln 4, that's ln of the base, and then you copy 4, so times 4 to the square root of x minus 2, and then times the derivative of square root of x minus 2. I also encourage students to just remember the derivative of square root of u. Although we don't have a formula for that, but because this usually comes out, then just remember the derivative of square root of u will just be 1 over 2 square root of u. That's the derivative for that. So here the derivative of the square root of x minus 2 is just 1 over 2 square root of x minus 2. Now times the derivative of the new u here is just x minus 2, which in that case the derivative is just 1. You don't need to write that 1 anymore. So you can just input your answer like this, and MyMathLab would accept that. Next, we have this problem here. Find the derivative of this function. You have t to the 5th times ln of t. In this case, we are to use the product rule because you have a function here that is an expression in terms of t and another expression that is in terms of t, so that's another function. So in that case, you're going to use the product rule to differentiate it. Now we are asked to find the derivative of ln of the absolute value of t. So this expression here, the derivative for that is just 1 over the absolute value of t, or just 1 over t. So to find the derivative here, we use the product rule. So you copy, again, the product rule is u, so this is your u and this is your v. So the derivative of u times v with respect to x is just u v prime plus v u prime. So that is just equal to u, which is t to the 5th times v prime, so 1 over t, and then time plus u, so that's times v, which is ln of t. So we're just making sure here that t is actually positive. So ln of the absolute value of t times the derivative of u, which is 5t to the fourth. You may simplify this. That is equal to t to the fourth, right? Or you can leave your answer like that. Let's probably just go ahead and simplify this. So we have that cancels. So you have t to the fourth ln t times 5t to the fourth. So that means you can factor out t to the fourth, and then you will have 1 plus 5 ln absolute value of t. That's the answer. Now let's consider this function here. Find the derivative of this given expression. Now we have a quotient. So in this case, we're going to use the quotient rule. So if you recall, the quotient rule, you could think of this as your u, and then denominator is your v. So the derivative of u over v with respect to x is just equal to low, so that's v, the high, u prime, minus high means the numerator, u, the low, v prime, all over v squared. So again, it's low, the high, minus high, the low, all over low squared. Now, let's apply that to the given expression here. So you have y prime, that's your dy dx, is equal to v, that's low, so it's 3 plus 5x, enclose it in a parenthesis, times the derivative of the numerator, 4 times the derivative of ln 4x. The derivative of ln 4x will be 1 over u, so 1 over 4x, times the derivative of 4x, which is 4. And then minus your u, so you copy the numerator, 4 ln 4x, times the derivative of the denominator, which is just equal to 5, all over low squared, 3 plus 5x squared. Now let's try to simplify a little bit, okay? Or you may leave your answer like that. So you can just write it as 3 plus 5x, and then times 4 over x minus 20 ln 4x, all over 3 plus 5x squared. You input your answer like this, or you can input it like this, you know, the first line, and MyMathLab would accept that. Now let's find the derivative of the following function. So here we are to use first, if you notice, we have a quantity here raised to 5. So that means we are to use the power rule first. And then when you differentiate your u is ln of the absolute value of x plus 4. So when you differentiate that, you use the derivative of ln of u. So now the absolute value here is just used to indicate that this expression here needs to be positive. So when you differentiate that, you think of that as just your u, you know, as without the absolute value. So the derivative of ln of the absolute value of x plus 4 will just be 1 over your u, which is x plus 4. Just write it as x plus 4. Okay, so as I've said, this would be your u. So in other words, that is of the form u to the fifth. So you just differentiate that, the derivative of u to the n with respect to x is equal to n u to the n minus 1 times the derivative of u with respect to x. So in other words, here you will have 5, so you copy 5 first, and then your u is ln, so you have ln of the absolute value of x plus 4 raised to, then you subtract 1 from the exponent to the fourth, times, now you differentiate your u, so now you differentiate ln. So the derivative of ln of the absolute value of x plus 4 is just 1 over x plus 4 times the derivative of x. So that is just 1. And that's the answer. Now let's find the derivative of log of the square root of 9x plus 4 base 5. So the derivative of logarithm of different base, so if it's not ln is logarithm base e. So that means if the logarithm is no longer base e, so that like in this case here, which is base 5, we have a different formula for that. Now the derivative of, with respect to x, of log of u base b, so a different base other than e, is equal to 1 over ln b times 1 over u times the derivative of u with respect to x. So now, before you differentiate this, especially if there's logarithm, try to apply properties of logarithm first. I hope you recognize that square root of 9x plus 4 could be written as, so let's rewrite this, 9x plus 4 raised to 1/2. That's log base 5. So we can use the power rule, properties of logarithm. You can bring this over here, so that is equal to 1/2 times the logarithm of 9x plus 4 base 5. And now, after you have applied that property, then you can talk about finding the derivative. So the derivative, so that is your y, the derivative of y with respect to x is equal to 1/2, copy 1/2 first, then you apply this formula, 1 over ln of the base, which is in this case 5, times 1 over u, so 1 over 9x plus 4, times the derivative of u with respect to x, so times the derivative of 9x plus 4, which is 9. And that's the answer. Now for this next number, we are to find the derivative of ln of the expression here. So as you notice, there's no property that can be applied directly to ln. So therefore, we go ahead and use chain rule to differentiate this. Now if you use chain rule, you would think of this as your u. So that means you are going to find the derivative of ln u first. So the derivative of ln u with respect to x is just equal to 1 over u times the derivative of u with respect to x. So this is equal to, that's f prime, is just equal to 1 over u, that's your u, x e to the square root of x plus 1. So that is your 1 over u. Now you differentiate u. So when you differentiate u, notice that you have to use product rule here. So you're going to apply product rule here when you differentiate that. So times, you copy x first, and then differentiate e to the square root of x. The derivative of e to the square root of x is just e to the square root of x times the derivative of square root of x, which is 1 over 2 square root of x. Plus, then you copy e to the square root of x times the derivative of x, which is 1. And then plus the derivative of 1, which is just 0. So enclose that. And that's it. That's the answer.